Alright, hello guys and welcome back to our tutorial series. So the last time we talked about some optimization strategies, we talked about some caching strategies, and of course logging and monitoring. So in this tutorial, what we would like to look at would be input validation, and of course topic like protecting the database from attacks like SQL injection. And it's going to be laden with a lot of information, so I would encourage you to of course play at your own pace and go back if you need to. So I'm just going to go ahead and check out a new branch for this tutorial, and I'm just going to call this maybe advanced practices, something like this. And we are in a new branch, and I'm just going to go ahead and close the terminal. So we'll take it one after the other. So we'll first talk about, of course, input validation. And so under input validation, there are a few things I would like us to look at. And so the first thing that we'll look at here more or less would be, but before we even list these topics, so the point of input validation more or less is to, if you can imagine already, if you have an application whereby you would need to accept input from a user, where the user would have to input some parameters and then you process them. So this could already open up a lot of vulnerabilities to your application, because if you do not sanitize the input that the user provides, because this could actually become more or less a problem for our application. The person, if they know what they are doing, could actually do some malicious attacks, or actually you try to actually attack your database or whatever. And this would this can actually exploit certain vulnerabilities, more or less security vulnerabilities in your application, and then through things like, say, SQL injection, cross-site scripting, and also like maybe remote code execution. And so these are some of the things we would like to talk about in this tutorial, because we would want to, of course, bring your notice to it, and then maybe talk about how we can, some of those possible attacks are, and how we can actually protect against them. So we would like to I would maybe talk to you a little bit about some of these possible attacks. And the first thing, of course, would be, say, SQL injection. And the next one would look at would be, say, cross-site scripting. Cross-site scripting. The next one would be common remote code execution, or simply RCE. And cross-site scripting is mostly written as XSS, like this. And the next thing I would want to talk to you again would be maybe paths traversal. And maybe the last thing we can look at here would be command injection. So we're going to take each of them one after the other, and then hopefully be able to explain to you what each of them mean in the end. So SQL injection might already be pretty straightforward for you if you have heard about this in the past, but if you haven't, that's totally fine. So, but SQL injection basically occurs like when malicious SQL statements are actually injected into your application, you know, and this could allow like unauthorized access and manipulation of your database. And in, of course, worst case scenarios, that could actually result in complete deletion of your database. So if you imagine a scenario where you have like a users table, if you do not protect against this and you expose your application to SQL injection, it could happen that someone could maliciously actually drop your entire users table, and that's a possibility actually. And with cross-site scripting, so this actually involves like injecting malicious client-side scripts into the web page. So this would enable attackers to hijack user sessions, like steal sensitive data or perform unauthorized actions, of course. And with RCE, remote code execution, so it's in this case also, of course, it's also a vulnerability, but again, this allows attackers to execute arbitrary code on your server. So you can also imagine this would, of course, compromise your entire system, because now your backend, of course, is the heart of your application. And path traversal, this attack exploits improper input validation, like to access files and directories outside the intended scope. So it could potentially expose sensitive information and enable, of course, unauthorized modification of your files and folders, as the case may be. And of course, finally, with command injection, so it's a little bit similar to SQL injection, but it allows command injection attacks, which involves, of course, injecting malicious operating system commands into application entry points. And you can imagine this will grant attackers unauthorized access or control over the entire system. So these are some of the, it's not an exhaustive list again, but these are some of the possible attacks that could actually happen to your application just from not doing like proper input validation and sanitization. And so what we can now do more or less would be to again go through each of these topics and see how we can actually provide some of these attacks from happening in the first place. So for the possible solutions, I would like to group this into two more or less categories. And maybe I come down here, I say maybe solution. I never thought we'd actually have to come in here and write a couple of things, but that's of course okay. So here I would, like I said, I would like to group our solutions into two main categories. And the first one, I can call this maybe user input sanitization and validation, something like this, if I can spell correctly. And other than this, the next one, the next group, more or less, we can also have, I can maybe call this like two, I can call this some like context aware prevention, some like this. And then we can now add flesh to some of this by also providing some examples. So under this user input sanitization and validation, I can provide more info like this. I can provide some examples and then we'll talk about it. So we have white listing and black listing. And we also have, of course, so this now more or less would go more or less in the direction of possible solutions we could use. So the next possible solution would probably be in the direction of using regular expressions. And I'm also guessing you already know what regular expressions are. If you don't, I would hopefully give you a quick introduction into it. So here we could also use maybe some third-party libraries to actually help us do user input sanitization and validation. Okay, and that would be some of the possible solutions we could do as it pertains to user input and sanitization and validation. And for context aware prevention possible solutions, one of the things we would want to look at here would be, so I can maybe just call this SQL injection prevention, where I would specifically target the prevention of this kind of attacks from happening in our application in the first place. And the second one, of course, would be SSS prevention. And of course, on this topic, the last but not the least would be our RCA prevention. And now we can actually go through each of them, and then we see how we can actually solve some of these problems that we might have in our application. So the rule of thumb more or less would be to assume that for every time you expect an input from the user, the rule of thumb is to always assume that it could actually contain malicious information, and it could contain like some malicious commands, or that it could actually be a possible attack on your complete setup. This is the rule of thumb. Always assume that every input that you get from the user is not what you would expect it to be. And that's always like the first thing to always have in your at the back of your mind, more or less. And so this would of course save you the problem of making some wrong assumptions as regards user inputs. Okay, so and regards pertaining to solutions, like we said over here, we have like white listing or black listing. So So with whitelisting, this actually just involves like defining a set of allowed characters or patterns and then rejecting any input that falls outside of this set. It's pretty straightforward. While blacklisting is like the converse. So it involves defining a set of disallowed characters or patterns and then rejecting any input that matches them. So there is more or less they do the same thing, but of course, like they take a completely different approach. So they have their own merits and disadvantages and everything, but whitelisting is generally considered more secure because it's easier to overlook potential attack and attack vectors, and when of course relying solely on blacklisting, for example. So the next thing would of course be regular expressions, and we can maybe also use some examples to show what could possibly be a use case here. So I can maybe come into the main file that we have here, and maybe I'll just create a new function over here, and I can call this let's say some like validates user, or maybe validates email, whatever, something like this. And it takes an email, which of course is going to be a string, and then it's going to return a boolean. So if it is valid, it returns true, and of course, the converse is the case. So the point is that if our application expects a user to provide an email, like I said initially, always as a rule of thumb, assume that this email would not be an email in the end. That's really the rule of thumb. So one quick way we can actually go about this will of course use the inbuilt library, of course, that comes with Go, which is of course the regex library that comes pre-built, of course, with the Go library. Okay, so I have piece of code I wrote already in the past. I'm just gonna paste that in here, and of course here would be my email. And now what we can actually do is maybe I just comment this one out. And maybe I can actually name it, give it a more fitting name. I can call it is email valid, something like this. And now I can actually print this, and I can say is email valid, and I provide some dummy email. I can say some like test.user@gmail.com and save that. And now open our terminal and test it out. And then of course we get true. And then maybe if we removed at, for example, and try this out one more time, and this should tell us that this is wrong. And of course, if you can see here, we are using regular expression to more or less write our own what kind of string we expect as when it pertains to an email input, for example. So apart from being an input field, if, for example, we are expecting, let's say, some characters, then we can of course still use regex to make sure that we accept only characters and not some special characters. We can also of course make sure that we like I already we talked about here already, we can actually use like this whitelisting or blacklisting concept to more or less take out certain keywords that we would not be expecting the user to provide us with. And of course, apart from using this regex package, there is also of course the mail package that also comes pre-built with Go, and we can get it like this from here. So net./mail, and that would be the package. And then of course to use this is also pretty straightforward. What we can actually just do, we call it this way, email.parse, and we should be able to do address. Oh, sorry, not email. Come on, mail.parse address. And maybe I can actually parameterize this. I can call this email, and I'll bring it over here. Email would be this. And now I can also put our email in here. And of course, this returns more or less an error. We can actually hover over it to see what we get. So we get an email and an error. So we can actually handle this here. So I call this, maybe I don't need this actually. I'm only interested in the error. And then we can handle the error like this. For scenarios whereby this error is not nil, now we can actually maybe print some like fmt, and we say some like the email is invalid, whatever. And then maybe what we can also do is just to, why not throw in an else statement down here, copy it, maybe provide the em here, whatever, and now we actually just print it down here and provide an email. And we say, of course, the provided email address, something like this, I don't know. And then I'm going to mean to close that, and then we run our application one more time. And now it tells us, of course, the email is invalid, as we also get false here. But again, if we go back again to provide our add, and then save that, and then run our code one more time, and this should, of course, tell us true. And then, of course, we get to this point, of course, which means that this is valid. It didn't exit here anymore. So this is actually what it means by working with regular expressions and stuff like this to actually validate the user inputs. So these are some of the possible ways this can actually be achieved. So like we said over here, the next thing, of course, would be maybe to use some third-party libraries. And there are certain libraries, of course, like Blue Monday, that can actually be used to sanitize like HTML inputs, just to be sure that the users provide data similar to what's expected. And I'm going to leave a link to the library, more or less, and just for you to also try it out. But maybe what I can also do is to show you an example of how this could actually be used. Okay, so what we can actually do now is one of these packages that we can use would be, like I said, Blue Monday. And then to install this, I'm gonna install this, of course. This should be from GitHub. If I can type github.com/microcosm cc, and of course Blue Monday. And then to use this, more or less, is actually pretty straightforward. And maybe down here I can see some like sanitize inputs, and for this case we considered only email. Again, you can utilize this to take care of other forms of inputs. So now down here we'd like to, let's say, sanitize let's say HTML files, for example. And then that's where this actually comes in. So I can have file something here called HTML inputs. This is going to be a string. And then I can instantiate the Blue Monday this way. I can call this, I can just call it policy. And then Blue Monday dot ug, I think it's UGC policy. I don't know. We will see. And we got a tidy. So I open this up. Come on. Oh, go mod tidy. And yeah, we found the package. And then of course I can close this up one more time. And now we have this. So I think it should be actually policy. And now what I can actually do is to use this and say policy.sanitize. And then I provide the HTML input this way. And then in the end, I get a sanitized HTML file, HTML string, more or less. I can call this sanitized input like this. And then maybe I simply just print this for now so you see. And I provide this, and I can maybe add a string so we see what's going on. So I can say like this sanitize HTML input file, whatever, like this. And then maybe what I can actually do is maybe to actually come here and define a simple HTML. So it's going to be a div, and I close the tag this way, div. And of course, within HTML you can of course provide some scripts, and this will always be within the script tag, scripts like this. And then inside here we can actually add some scripts, and maybe I do some console.log, and I say something like let me close this up first. So maybe I use single quotes for now. No, I want to use double quotes. Why not? I'll just have to change this to carrots, of course. And then I can say scripts inside HTML file, whatever, something like this. And now this, because we do not want the use, of course, embedding any scripts, for example, in scenarios where we do things like, say, server-side rendering or whatever, we would not want to have scripts more or less being injected, especially if it is coming from a user input. And this way, maybe we have some form where we serve to some users through our application some way, and then we are sending this to the backend as a HTML file, for example, and we want to make sure that this doesn't even get through in the first place. So to sanitize this, I'm just going to open our terminal again and then run our application, go run main.go. And then what's going to happen is that when it sanitizes this HTML file, is simply just going to throw away any script tags in between. So what it means that for this case, if there is any form of embedded script in this HTML file, it's just going to be thrown away. It's not going to work at all. Again, just these are just pretty simple examples. There are lot more we can actually do with this library. But again, I'm just going to let you to explore, of course, on your own. So the next thing, of course, that you can already imagine is that if it happens also that instead of us expecting this in this way, of course, you can imagine if we, let's say we have, all like we already did, where we have like some structs like this, where we get the inputs this way, more or less, and the request coming in, let's say as a post request, and then we bind this to some JSON and then read out from that JSON. We already did something like this in the past where we use this binding more or less to, of course, validate some of these inputs, because again, this can already, of course, be going in this direction. And that's also why if you look into what we did already, let's say in our create user, we actually use this method over here. If I can find it, this, where is it? Where did we use it? Let me find that quickly. um I think I can actually just go to errors, I think. Is it in models? I can't remember actually. UTF errors. Yes, we already did something like this where I use this, where we use this validator from the Go playground to do some validation to more or less make sure that fields are what they are. Again, apart from using this package, there is also a different package called Go Validators, and it also has a lot more features. It can also do a lot more validation and much more actually. So these are some of the third-party libraries that we could actually use to achieve the same purpose as it pertains to, of course, validating our user input, just to make sure we get what we want to get. And anyway, so that would be it for third-party libraries. And now we are going to talk a little bit about our contest-aware prevention. And here I'm trying to move as fast as possible just so we don't lose so much time. So again, we said with SQL injection, the user or the attacker can actually have unauthorized access to our data, and they can end up manipulating our data and compromising our entire system. And of course, this would be really bad for us, and we don't want this to happen at all. And maybe what I can also do is to maybe show you an example in case you don't know what an SQL injection um, attack actually looks like. This would maybe show you some throw some light more or less, so you can actually begin to understand what this means. So imagine, for example, I'm just actually so I'm probably going to, just like I did here for cache, and this guy, I'm probably just going to create a new file here so I don't clutter our main file. I can call this user, I can, oh no, I can actually this input validation.go is going to be within the main package. Come on, always making that mistake. It's going to be within the main package. That's totally fine. And I'm going to create a function here, and I can call it validation, whatever, like this. And this is what we can actually use to play around a bit. So imagine there is a scenario whereby we are working with, say, an SQL database, and then let's say we do something like SQL.open open like this. Come on, help me. And then I provide, of course, the driver would be my SQL. And now I provide more or less some information. So this will actually provide credentials to the database. I can, for now, we're just going to assume you have something like this. We have the user name to the database is user, password is password, and I don't know, something like this. Doesn't really matter. So imagine a scenario whereby we are establishing SQL database connection this way, and of course, maybe of course, we would need to provide some driver. And this, of course, would come from our github.com. I think this should from Go SQL driver. I'm not sure how to MySQL. I'm not sure. Okay, I think that's also okay. So this gives us as you can see, this is a driver from MySQL. So imagine a scenario whereby we are working with this SQL database and we've established connection this way. So I can call this DB and error. These are the two things we get back. And then we handle our error. So we say if this error is not equal to nil, maybe here I'll just do a log.failure, for example, and we just fail with the error. So now we have our DB, and then maybe, of course, to follow best practices, we defer DB dot close like this. And now we have our client. And so imagine this function accepts let's say you call it username, or maybe let's just keep it simple. Say email, this is going to be a string. And now what we want to do is to write a raw query to our database. Okay. And then let's say our query goes something like we'll do some like db.prepare, for example, and then we actually provide our query string. And let's say our string is something like let's say select, select so I'm going to select everything, of course. Select everything from, let's say our database is called users. Select from users where we have email, and we say this is equal to this, and where would we like to provide some parameters more or less, and we can handle the error again here. So we get our statement and error, and then again I'm going to handle the error, just the points. I don't want to waste time because this is really not what I want to show you. So we handle our error this way. Again, I'm going to defer the closure of this statement and defer the closure of the statement. And now we actually make our query statements dots, and we'll make our query this way, and then we provide this email. And then again, this is going to give us rows and error like this. So again, we handle our error, and now we have our rows. And then let's say I defer rows closure like this, and then yeah, we'll do some further we'll maybe now do our marshalling, for example, to a user struct, something like this, and then we return to the user. So if we use this function this way, I can call this func. I'm running out of names. And if we have this function, I can call this form actually. If we have this function called form, and this function is supposed to invoke this validation, I think I'm gonna rename this to, let's say, fetch user. I think this is much more befitting. And now I can define a user email like this, and maybe I provide some dummy email, say tests dot user at come on gmail.com. And now, of course, we call our fetch user and provide this email. So if this is okay, then of course, and then we have such a user with this email in our database, we should be able to fetch this user, no problem. But now imagine what if what I actually provided was something like this, just so you have an idea of the problem. Imagine if I provided this and then I added another thing behind it and I say drop table users. Imagine if that was actually what I provided. Just take a minute and imagine what could happen. So if you've taken a couple of seconds or minutes or whatever to actually imagine what's going to happen when we execute this query, then you would understand what it means, what SQL injection attack could mean. So if we run this query, now more or less what this actually is here is actually two queries. So this would of course come in here. In the end, we're going to have something like this. So this would now become something like this actually. So we would fetch from our user table where email is equal to this. And then this is a separate table that simply says drop the table. And this would be catastrophic, of course. We don't want that. So that is SQL injection for you. Um, yeah, so let's again talk a little bit about cross-site scripting. So we already talked a little bit about some possible problems we could have from this. So we already said this will introduce like critical vulnerabilities, that can lead to session hijacking, data theft, and other malicious actions. So, and to prevent this, what we have to do or what we need to know is that it's quite essential to validate and sanitize every user input that is rendered on web pages or other contexts where client-side code can be executed. And within Go, of course, there are a lot of built-in functions and packages to help to mitigate XSS vulnerabilities. And one of them, of course, would be, let's say, HTML templates package, which would, of course, help us to handle scenarios whereby there are HTML files that we'll need to take care of. And I'm also, if you don't know about this, I'm just going to provide you, of course, I think I don't need to actually even provide it. It's pretty straightforward. We have this package over here. I think it's actually called, one second. Yes, called HTML template. So this is one way, and this could also be found useful for us regarding the topic we just covered. So of course, feel free to explore some of these possible options, and then of course figure out which one works best for you. And then so for remote code prevention, this I would like to talk a little bit more about it and maybe also show you some examples. So it's really crucial, like we've already said, to make sure that every form of external inputs that we get in from a user is always sanitized and validated. And just to make sure that we don't fall prey to some of these problems. So to give a quick example, of course, I'm just going to save this because we're not using this, but this is I just wanted to call your attention to this. Anyway, so the next example, of course, I would want to show you would be, of course, as it pertains to remote code execution. So if we ever have to do something like this, it also makes a lot of sense that we validate this. Because imagine, for example, that if we expect some input from a user, and then with the inputs, maybe we have to do some is code execution or command execution, more or less on the server side. And you can also imagine that if the user provides us things like, for example, or let's say, for example, the ls command, maybe look into our temp file, and if we execute this command that we exactly get from the user, this will, of course, give them access to files they don't have permissions to view, more or less. And this is just an example. If a user, if you can already imagine, if this command can get through whereby you have the option of listing the content of a certain folder, then you also know that it might also happen that deleting of files can also happen. So this is also where, that's apart from just sanitizing the user, it also makes a lot of sense to give files and folders, especially the ones that might be exposed to the user by the virtue of the kind of application we are building, to give them certain permissions. And what I mean is that to make certain files or folders read only, or stuff like that, so that we don't run into scenarios where people delete files they have permissions to where they have permissions to delete files that they only need access to view and stuff like that. So basically also incorporating the concept of least privileges, where users get the only right amount of privilege they need to do what they need to do and nothing more. And yeah, I'm just also gonna get rid of this. Just wanted to show you that example so you have it at the back of your mind. Anyways, guys, that would be all I wanted to show you here. It's a lot, I know, and of course it's actually extends more than we are actually talked about in this tutorial session. But of course, the goal has always been the same, of course, to call your attention to some of these things, to make you aware of them, to show you how to, like, to explain to you the meaning, so you understand the basics more or less, and then you can, of course, maybe expand on your imagination, and then grow from there. Basically, that's really the point of these tutorial sessions. Anyway, guys, that's would be all I wanted to show you in this session, and it's a really packed one. I will try to remember to put every possible link that I promised to provide, and even much more, to provide you, of course, enough resources so you can always have this as a point of reference to go back to them, read them up much later, and then grab possible information you would ever need from them to do your work. And yeah, feel free to reach out to me, of course, if you have questions, or if you would, of course, have some topics you think that I might have skipped, or that should also make it our list of things to consider. Feel free to reach out to me. If you have questions, if you want to engage me, of course, feel free to do that. I'm always actually looking forward to it. Anyways, guys, that will be all for now. And of course, you know what to do. If you're new to our channel, or if you've never subscribed, please go ahead, subscribe, and we promise to always bring you practical, important information that will help your development journey. Anyways, that will be all for now, guys, and until we see each other next time, have a lovely evening, and bye bye.